Sure. Sounds good. Thanks, Shane, and thanks, Denise. Hello, everyone. Welcome to our webinar about Microsoft Fabric. My name is Imran Ullah, and I am the sales leader for the Eastern Canada region. So just wanted to share with you a little bit about what Centrilogic is as a company, and then we'll jump into the content for our session today. But, Centrilogic is an IT services company. We're based out of Toronto, Canada, and we service customers all through North America and Europe. And we partner with companies to really try to build and innovate custom end-to-end solutions. We do everything from cloud strategy and migrations to managed services, cybersecurity, and our goal really is to optimize at every level of the stack on infrastructure, trying to find ways to reduce cost and drive performance for our clients. Our team is a collective of industry experts. We use a customer first approach, and we really try to help organizations embrace modern architectures and build new application models. And this is the digital landscape is ever evolving, and it's really important for us to try to keep up. And we definitely think with some of the new advances in technology over the last year around data and AI, it's been just really trying to the industry is really exploding in terms of the level of efforts it's requiring our clients to try to keep up with that. Our partnership with Microsoft has been really strong. We're great relationship with Microsoft. We're a tiered member, and we've got tons of certificates and expertise in that area, especially in the data and AI space, in automation and productivity. So, as we jump into as I hand this back to Shane to kick off, I just want to make sure that you guys please feel free to ask any questions. We'll be monitoring the group chat for questions, and we'll try to get to them as we go through the session today. And over to you, Shane.
Thanks, Aaron. Okay, hello everyone. Welcome. So here's today's agenda. So we're going to be talking about the enterprise data space. Today's talk is about Microsoft Fabric, data analytics in Fabric, and its AI capabilities. So I'm going to go through all the components of Fabric and then finish with a couple of demos of Fabric in action. So I'm going to talk about data storage, the Lakehouse, what that is, why that's important, OneLake, data integration, which is Data Factory, and notebooks, Fabric notebooks. Talk about data science, how models are built, and the AI capabilities both within Microsoft Fabric and the ability to connect external agents to Fabric. Talk about real-time intelligence and real-time data, and then lastly, visualizing, reporting, how to surface up this data and give it to your users. So again, if you do have any questions, put them in the chat, please. We will be monitoring that, and I'll have a section for questions at the end. I'll go through the questions in the chat. So let's talk about enterprise data today. So enterprise data, there's a lot of challenges in data. Most enterprises today have a collection of data. There's multiple data silos. You might have multiple data warehouses. You may have multiple reporting solutions. Bringing all of that data together is an important part of building a comprehensive data solution. There's a lot of complexity in getting all the data together, getting those integration, multiple tools. Again, there's lots of infrastructure to host, a lot of licensing costs associated with that many times. Then as data is growing, we want to collect more data to get more intelligence, especially with today's growth in AI. AI needs more data, so we're collecting more data than ever before. How do we manage that scalability? Then how quickly can you get information and insight from that data as the world is changing ever faster? How do we make sure that we take actionable insight from the data and leverage that before that insight is no longer relevant? So faster access to insight is very important. And while all this data is being collected, keeping it secure, making sure the right people have access to the right data and not data sprawling where everyone has access, and being able to audit and visualize how the data is being used and accessed to stay compliant. And lastly, surfacing up this data in a way that AI agents and AI solutions can use this data, that end users can ask questions of their data, and that AI agents are able to autonomously work with data in your environment. So the data market today, here's a slide showing the current, the 2024 marketplace for data solutions. As you can see, there are hundreds of companies here across all kinds of areas, including infrastructure, analytics, machine learning. This entire complexity, you can go in and individually select components here. It's a job on itself, or you can look at a comprehensive solution that brings all of these together, and that's what we're talking about here today, which is Microsoft Fabric. So Microsoft Fabric is basically the Microsoft solution of everything you saw on that previous slide, collected together into one platform, one product, one set of data where you pull in your data and ingest your data with Data Factory, use data science and normalization tools to create analytics, to create your insight, consolidate all those data sets together into one lake, get real-time intelligence and report it. Then AI has access across the board of all this platform, and the data is hosted in one lake and all secured and governed by Purview. So I'll be going over all of these components today and wrapping up with a demo. So that's what we're talking about here today. So Fabric, Power BI has been in the marketplace for quite some time. Fabric brings together a series of previous tools in the Microsoft platform and brings them all together into one solution. And prior to, so Power BI has been around for quite a few years, and there's over 375,000 users of Power BI today. 95% of the Fortune 500 are already using Power BI. So Fabric is really bringing all of the rest of the data platform into Power BI, bringing Power BI together, as I showed on that previous slide. So now I'm going to start talking about each component, and I'm going to start with OneLake. Start with the storage platform that sits at the bottom that everything rests on, and then I'll build the platform up from there. So the innovation in recent times is what we're calling the Lakehouse, and the Lakehouse is a combination of a data lake, which would be unstructured data, and a data warehouse, which is structured data. So Lakehouse, data lake, data warehouse together is the Lakehouse. And the important thing here is that you have relational access to data, so standard SQL queries, and access to Word documents, PDF, images, click streams, application logs, all this kind of unstructured data that traditionally was in a data lake and separate from a data warehouse, and doing any kind of analysis or exploration that joined across historically has been difficult and challenging, and that's what the Lakehouse architecture solves. So why is that important? You may have reports that just run SQL queries that give you summaries of sales by store, that kind of thing, and you may be doing machine learning, and machine learning relies on tabular structures, Spark, things in the data frame structure. So having access to both of those together is important. Secondly, a Lakehouse, if you have a traditional data warehouse, something like SQL Server or Oracle, the server that runs the compute engine and the storage are tightly bound together. This makes it very hard to scale past a few hundred gigabytes into petabytes or multiple petabytes of data. And also the licensing and charge for those massive servers, if you need to ramp up your storage, you're also typically also ramping up your compute charge. In the Lakehouse architecture, those are separated. So your data is stored, and the Parquet and Data Lake, Delta Lake formats enable that separation so that you maintain the ability to copy multiple copies of data, and you're essentially using cloud file storage to scale as much data as you need. And then again, inheriting that security and governance. So the security and governance is going to flow through throughout the presentation, that the Fabric platform does RBAC and security the same way across all the components I'll be talking about today. So another innovation from the Lakehouse architecture is the idea of a medallion architecture. So the medallion is bronze, silver, and gold, like the Olympics. Bronze data is your raw data coming in from multiple data sets, multiple databases, files, log files, all these kind of things, and has not been normalized and transformed so that everything matches up. That's what happens in your silver and gold levels. At the silver level, you're making sure all the customer IDs are the same across data sets, that the date formats are the same, that lookup tables have been done. So you have this cleaned up data set that's ready to use for different users. And then we move into the gold data. And what gold data is a specialized view. Your sales team may want to see a customer-focused view. Your operations team may want to see performance and customer satisfaction, that kind of thing, as a different view of sales. It's the same underlying data, but it's different views. So every team gets their own specialized views. And in the past, you may have said, oh, this team wants this report that may require spinning up a whole different database for them, or a different set of individualized, customized content that may require separate replication. By bringing it all together into the Lakehouse, that you're able to stack on this. And the beauty of the Lakehouse architecture is the silver and gold are layers of views on top of the bronze data. So you only ever keep one copy of your data. And that's something new, that as we scale into these very, very large data sets, keeping multiple copies of your data is very expensive. So this architecture allows you to keep one data and apply these transformations on top. And that's how they're viewed out to the end users. So Microsoft's implementation of the Lakehouse architecture is called OneLake. And if you used OneDrive, you can think of this as an enterprise version of OneDrive that is effectively infinitely scalable. It can go from tens of gigabytes, it can go from a megabyte to tens of petabytes with no scaling requirement. You just keep copying files in, it's auto provisioned, and you're charged per gigabyte stored per month. So that's it. There's no requirement for managing any kind of infrastructure of any kind. You just copy your files in and everything is handled automatically. You apply your security and governance controls on top, and that's all automatically taken care of. So what does this look like? All the components that we will be talking about here: data, the ingestion tools, the analytic tools, database mirroring tools, real time, all of it goes to the data lake, to OneLake. That OneLake is the single place for everything. Now, you may be saying, well, I don't want my data mixed and mingled with other data. You have the ability to create workspaces within OneLake. So you can carve it into separate sections. So there's very strong security controls that separate the different areas of the OneLake so that it is truly the single source. As far as bringing things in, you can create what's called a cross-cloud shortcut. So let's say you have a large AWS environment where you have a large S3 data that you want to query. You can create a shortcut to your data so that your data is not copied over. When you run a query, that'll automatically send the query over to S3 and pull in the files that you need. Same goes with all these other providers such as Databricks, Snowflakes, and your on-prem data. So you may have on-prem databases that you want to run Fabric reports against, and you can pass through that query via a cloud shortcut. Now, that may impact those systems, and you may not want to put load on those systems. So there is the option for full data mirroring. And what this is a transaction by transaction full copy of the data set in real time as it happens. So the solutions in the top row, Snowflake, Cosmos, and Databricks, Unique Catalog, are all fully supported this time. And for SQL Server on-prem and Oracle is coming soon, meaning as transactional changes are happening in your underlying systems, say you have ERP that is running on any of these databases, they'll be automatically copied into to Fabric, and that's what enables a lot of the real-time intelligence that we'll be talking about later in the presentation. So just some market facts about OneLake. There are currently 21 billion interactions with OneLake every single day. So it lives in the Azure, on the Azure infrastructure, but Fabric itself is a SaaS product. So it's separate from Azure. It's not an Azure product. It is a much like Office 365 is a SaaS-based product offered by Microsoft. Fabric is the same, a SaaS-based product that runs on the Azure infrastructure, but that's transparent. There's 4 million shortcuts currently in production out to those cloud connectors I talked about, 1 million plus storage accounts under management, and the rate of data being stored in Fabric is doubling every 4 months. So this is staggering growth going on in OneLake. So that is the overview of the Lakehouse architecture and OneLake that underpins all of the Fabric solution. So let's talk about data integration. So data integration, for those new to the space or good refresher, is the process of combining data from multiple sources to create a unified, consistent, and accessible format to analyze, report, and decision making. Basically, you need all your data. Maybe your customer data is coming from one source, your invoice and financial system data is coming from a second source, your sales leads and your sales information is coming from another source. You may be getting marketing intelligence and market reports from multiple sources. You may have operational reports as well. However many data sources you have, the data integration processes where you bring all of that together and make it consistent and make it usable so that you can run reports and get the answers that you're looking for out of there. This can be done. Data integration can happen in a batch, like hourly, nightly, weekly, whatever schedule you want to schedule the jobs, or more and more these days going to real time. So as it happens in the now data. And just continuing the theme, the security and governance, the same model applies. So when you're applying the model to OneLake, as you're connecting to these external systems and bringing that data in, the data is secured during that whole process, the whole trip from the source into the lake, and the entire time it's in the lake and processed, the same governance and audit solutions apply. So how do we connect to the data? Fabric supports any of the Power Automate or Power Platform connectors, of which there are thousands. Most enterprise applications are already in there. All of the Azure components are in there. If you need to connect to any other cloud, be it AWS, GCP, Oracle, whichever cloud you're connecting to, things like Salesforce, HubSpot, all of these SaaS-based products, you can connect directly. And if your product is not directly supported, if it has an API, you have the option of a direct API connection. You also have the option of an ODBC just straight into the database. So wherever your data is, including flat files too. So that's not on the screen here, but if you just have raw data, whatever format your data is coming in, you're able to connect and pull that in. So what does Data Factory look like? How do we get the data in? They have two options. One is the low-code kind of visual option, where you create a set of steps in a visual designer. I got an example of it up here, where we're pulling in orders and order details. We're merging those together, and then pulling in customer data and creating a table called top customers. And so this is just a list of, combining all your sales data and your order data to see, okay, I need at any point in time report on who your top customers are, and this will be continuously updated in the background. This is the low-code option. There's also the notebook option. Now, the advantage of the notebook option is you can source control the graphical version as well, but here you're able to use Copilot to generate a lot of the text in the cells. So the notebook option, and if you have very complex integration needs, you have the option for code, and they are interchangeable. You can mix and match, and in many cases these days, a hybrid combination where you use the building blocks of the low code to say loop over different data. You do your advanced transformations and error checking in a notebook, and then you feed the results of the notebook into another one of the low code blocks. And this way you're able to do the easy things in low code and do the challenging things in the notebook, kind of mixing and matching whatever makes sense to you. And so to look at how that process flow works at a high level, so we're starting with our files, all of our data sources, bringing them in, doing those transformations, loading those tables into the warehouse where they'll be used by Power BI and the rest of the components. So that's data ingestion and integration. Now let's talk about data science and AI. So AI in the enterprise, as I think there's an AI note taker on the call here as we're speaking. I'm sure you've seen, AI is everywhere. And at Centrilogic, we've been thinking deeply about how do we best serve our customers? What does AI mean in the marketplace? Because it's, as a word, it's just AI. What does that mean? We see it in three categories, and these three categories interact. So the first is data analytics, and that's what we're here talking about today. Is creating predictive models. So this may mean you want some kind of information. You may want to know how your data fits together. You may want to see trends in your data. You may want to predict or forecast something going forward. So that'd be a analytical model, which is statistics, math, ML, as they call it, which is different than the middle category, which is personal productivity. And personal productivity, we're talking about chatbots. So of course, ChatGPT and Microsoft Copilot, where end users are interacting with the system. If they're business users, they may be drafting Word documents, working in Excel or Outlook. If they're developers, they may be using something like GitHub Copilot, where they're writing code. And in the case of Fabric, the Fabric developer may be using Copilot to develop the code or to work with the data, chatting with the data as it's, and we'll have a demo of that later on in the personal productivity space as to how a user could chat with the data. And then lastly is automation. So the term agentic AI, I think that's the term of the year for 2025, is AI agents. And these are independent, autonomous agents that are able to perceive the world. So either be triggered by an event happening or a schedule or an end user request, and then perform some task, perform a business workflow, and potentially interact with humans. In the case of an integration, an agent may start an integration between two data sets, and when it runs across an issue, say a customer name in one system looks one way, and the customer name in the other system is different, historical data integration would fail on that, create an error log, and someone would have to go in and take a look and remediate that problem, solve it, and get the integration back on its way. In an agentic or AI-based scenario, the AI could look at that, look at the two different customer data, make a reasonable assumption about what the answer may be, and draft an email to an end user, stop the integration, pause the integration for that transaction, email an end user and say, hey, I found these two records. They're different. I think this is the match. Do you agree? If so, I'll continue. If not, what would you like me to do? And then a human, just through email, could say, hey, here's the, do this, or yeah, that looks good. Continue along. And then the AI would respond back, okay, I've continued the integration, all good. So that'd be an example of an AI agent-boosted integration, completely facilitated by Fabric, and that is available now using additional tools, either a third-party agentic solution or the Microsoft Agent solution. And we will, if you enjoy this talk today, Centrilogic, we will be doing within the next few weeks a full seminar on agentic AI. So just take a look at your inbox for the invite for that seminar that's coming. So we'll be going through the whole workflow of that. But today our focus will be mainly on data analytics and personal productivity in the AI space. So how do we enable that scenario I just talked about? We create what's called the semantic model. So the semantic model is when you bring in all your data. So let's say Salesforce data, some invoice data from an ERP, from SAP, maybe customer service information from Dynamics. You pull all this data together and normalize it, but then we create a semantic model, and that you can think of it as a view or a collection of objects that says, okay, here's our customer, here's our products, here's our sales, and here's how they're all connected together, so that all those separate data sources, which, an Excel sheet and a database and a log file are all in different formats. The semantic model gives one view to query on. And this in Power BI has existed for a long time. You create semantic model in Power BI, and that's how you build your Power BI reports. Now we're exposing that semantic model to all the components of Fabric, and particularly the data science components. So this is very exciting and interesting that as data scientists, a running joke has been that in data science, 105% of the work is getting the data ready, and minus 5% is doing the data science. Now, that's tongue in cheek, but getting the data prepped is been a serious hindrance to data science to date. The semantic model and having an enterprise secured semantic model speeds up the access for doing the data science work and creating experiments and running those, validating those, testing them, so that your data science team can rapidly iterate on data models and getting that insight out the door. And then that leads into all the different functions. So semantic functions, which are ways to create new information at the reporting level. So this is kind of introducing almost application-centric type things that are related to reporting, because you may have a scenario where a report, you'd want information in a certain way, but there's no calculation anywhere that stores it that way. A semantic function, you can say, hey, take our sales and multiply by the season, and add any kind of complex logic you want and store that, and that'll be applied, and that can be used by any other reports or by any of the data models. So there's a lot of work there in the semantic features. But all of this semantic model, once we have that, we have a unified view, harmonized view of all of the information in the enterprise. Then we can start the data science process. So we'll say, hey, we have a problem, such as, we want better leads for our sales team, or we want to really understand what drives customer satisfaction, and we want to improve customer satisfaction. Let's find what the top 3 issues are that are leading to both positive and negative customer satisfaction scores, so we can do more of the positive and fix what's going wrong in the negative. So we formulate those problems. We say we're going to run an experiment that we're going to build a model, and we're going to choose which model type that applies to. Then we're going to run through the data and see which data, this is called feature discovery, that we're going to say what data influences which data. So in the case of customer satisfaction, we may say, okay, is it location based? Is it time of year or time of day based? Is it certain products? And by running different experiments, we can see how all of these features, all these parts of your data interact with each other and influence the particular thing that we're trying to isolate. So be it customer satisfaction or lead conversion or profit or whatever underlying model that's important. So we go through the experiment and model loop. So this, having access to the semantic model, speeds up the preparation stage because the data is ready in a format that's usable. The one lake, and I mentioned earlier, the data frame ready model, historically, you'd have a traditional data warehouse, and the data science team would pull the data out of the data warehouse and load it into their Delta Lake and Parquet formats, so that the way the tools, the data science tools work with, because Fabric stores all the data in that native format. Fabric has layered an SQL engine on top of that format, so for traditional reports to work, but the data science can work natively. So in this point, then we enrich that. So we're adding in data, we're pulling things together, creating these new enhanced views. And in the medallion structure, this would be the gold model. And out of all of that, we glean some insight. And then we measure that insight, and we repeat the loop to get even more insight. Fabric, so all that process, you may not have data scientists on staff. That skill set is in very high demand. Here at Centrilogic, we do have a full data science team. So if you are looking for that kind of work, we'd be happy to help you. Please reach out to myself, Imran, anyone on the team, and we'll help you out. But if you want to try this in a isolated scenario, Fabric has a feature called AutoML, which is automated machine learning, where you can choose one of these models. So do you want to predict if your data is somewhere or not, such as satisfied customer or unsatisfied? Do you want to predict if they're going to be one or the other based on the data? It'll go through and find all the features and look across that semantic model and try combinations of things that lead to satisfied or unsatisfied customers. You may want to do classification to say, hey, we have all of these sales and we don't really understand why some customers fit, or which customers, what are our segments? Your marketing team may have a perspective on what the segments are. Sales team may have a perspective. Operations team may have different perspectives. This one here can go in and find categories in the data either by industry or by sales volume, by company firmographics, by interaction levels, all kinds, whatever's in your data, find classifications, and these models will, given a new piece of data, say, okay, which category does this data fit into? Maybe a ticket, an incident ticket comes in, and you have you're dealing with a customer issue. The classifier can say, is this a high priority, medium priority, or low priority? The customer may have flagged it as high priority, but in fact it's medium or low, or the other way around, that an internal team has classified it as low when in fact it's high because of whatever components. Classification can take care of that. Regression is when you're looking for a number. So you say, what are sales in a region, that we can say, given this information, what are the averages? You may have a very complex thing where it's not easy to just add everything up and divide. You may need to look at other components. And once you pass 3 or 4 dimensions in your regression, simple math is not going to work anymore. You need to use advanced machine learning for that. And that's what the regression model is able to do. And lastly is forecasting. So this is the classic predict the future, given sales in a region, or all the features in a particular area, predict a value given on all the past data, and that in the AutoML will give you a function that you can say, just draw that line and predict the future, and we'll give you a numeric accuracy as to what it thinks the future may be. So how does that look? Here's kind of the UI screen. You kind of choose your data source, pick which one of the tasks that you want to do. And what this will do is, in the background, is create one of the notebooks I've talked about. So here's kind of an example, examining customer churn. You want to say, where are we likely to churn a customer, and what is driving churn, and what can we do to kind of get in front of that and maybe prevent some churn. And then, so the notebook, the code you can see here, there's 50 lines of code up above. That was all produced by AutoML. So historically, you need a data scientist to write that code. Now with AutoML, that code's auto-generated. You still need some skill set to go in there and understand what the model's producing. So it's definitely an accelerator, but it doesn't alleviate the need for some math knowledge and some skills. So just level setting that it's not magical, but it is certainly powerful. It does speed things along. So here, we have a graph of saying likely to churn and a percentage chance associated to the churn rate. So that's data science notebooks. And a new feature that's come to Fabric that is quite exciting is a GraphQL API. Now, what does this mean? This means that you have that semantic model, that normalized, harmonized view of all your data that's secured. Fabric can expose that as an API of GraphQL. And what GraphQL is it's like SQL. It's a query language that allows you to send in text-based queries that you may want to say, I want to see customers by month, or I want to see sales by product, or this kind of thing. That providing the text of the query, the Fabric engine will automatically map that into the semantic model to get the result. And this is when you see the demos, and I'll have one later in the presentation, where you type into Copilot and say, I would like to see this answer. That is calling a GraphQL. This is the engine that's enabling access to that data. So the important things here are that the security and governance, because one of the concerns around AI particularly is that the AI will just run off and do things in the environment. By locking down this API and running in the context of the user. So it's the security context of the user that accesses this API when it's asking a question. It may say, hey, what are the top salaried employees in the organization? If the user does not have access to that information, the AI will come back saying, I don't have access to that information. I don't know. Versus running in the context where it does have access to that, it'll respond back with the results of the query. And the nice thing here too is you may have heard of AI hallucination, where AI kind of makes stuff up or fabricates things. In this scenario, because it's generating the query goes to the Fabric engine where the semantic model has been vetted and normalized. It's using the semantic model engine to get the results. So the AI is not producing results. It's not hallucinating things. It's taking the results that come from Fabric that are tested, validated, all that kind of thing. And that's how it creates trustable data. So this, again, I won't be going into the AI, the agentic AI use of this, but this is the driver that allows AI agents to take action based on your corporate data that is unique to using any kind of external chatbot without access to your information can't really take sound business decisions because it doesn't know what's going on in your organization. Granting an AI agent access to this query in a controlled way, it can say, hey, let's contact customers where there's a churn risk, or let's draft an email out to new sales opportunities, or let's look at a product that maybe isn't doing so well. All these kind of things that you'd want an agent to be doing. This is the way that's done. So this is very powerful stuff and worth a seminar on its own. And like I said, that's coming in a few weeks. So please come on out for that and we'll talk about that there. Next subject, real-time intelligence. So real-time is coming to the bear, and this is basically having, if you've been in the reporting space for a while, typically, reports takes days or months. You may only get something quarterly or monthly. Now, real-time mirroring of the data means we have direct data capture as it's happening. This may be from IoT devices, but it may be from applications. Say you have an active sales campaign and you want to monitor social media. You can get real live responses from your social media as it's happening on that day. Then maybe your marketing and sales teams are able to react at real-time speeds. You may connect to an API where an API is sending information as it happens. So in agriculture, maybe this is weather-based. If you're dealing with shipping, or if there are flight delays, or any of these kind of scenarios that your business needs real-time access to information to take decisions on, and whether you have a data science model attached to it or just traditional reporting, either way, however you want to consume that information, the platform is here to pull that data in. Instant analytics. So that's the big thing with real time is it's the same reporting as we were talking about before. It's just that there's not this batch oriented loading of the data a week or month at a time. It's by the second, less than a minute as it happens kind of data. It's also cost efficient. Now, traditionally, if you wanted that kind of real time data, you need a lot of expensive infrastructure, and that infrastructure need to be sized to handle your peak load. With the Fabric infrastructure, because it's serverless, it will auto adjust and you're only charged for the data ingestion. So if your business runs 9 to 5, Monday to Friday, there's 168 hours in a week. Those additional 128 hours are waste that your infrastructure that you're paying for, but you need that infrastructure there in a historical scenario because you couldn't just turn it off. Well, now you have the ability that when there are no queries and there's no activity in your business, all the machine, the capacity reduces itself and you're not charged for any of that. So this can lead to dramatic cost saving. for real time. And lastly, security and governance, the same model applies. It's the same RBAC, the same governance, the same controls, same auditing, the visibility, your full chain of custody. Real-time data is treated the same as batch data as far as logging when it comes in, who has access to it, how it's been changed, and the full view of the data through the cycle. So how does real-time work? Microsoft's introduced the idea of the event house. So we had Lakehouse architecture that we talked about before, and that's for storing existing data in files. But when you're in real time, there's not time for the data to hit the file. You can persist the data to save it for further analysis down the road. But in the case of real-time reporting, you need an event stream that is in memory. It is happening and data is coming in, being pushed in as these events are happening out in the world. And that's what the event stream is. That's the set of data of things as they're happening. Social media posts, device inputs, maybe you're tracking vehicle data, GPS locations, maybe you're tracking outbound sales, how many sales calls are coming in, sales conversion rates, these kind of things all come into the event house, and then you run a query. So the query engine for the event house is KQL. This is a Microsoft query language called Kusto. It's the same as the same query language used throughout Azure for monitoring Azure components and Azure activity, real-time networking, that kind of thing. So that query engine, which looks very similar to SQL, and there are SQL to KQL converters if you're more comfortable with SQL. And again, Copilot can produce these queries as well. And all that gets surfaced up into a real-time dashboard. So in a real-time dashboard, they're called reflexes. So when a data event happens that is of interest, you reflexively run a query that produces a result that you may be interested in. And this can be put into a Power BI report, or it can be fed into other systems. So again, that GraphQL query that we were talking about earlier can feed either agentic AI that may want to take action based on something happening, or different third-party systems that you may have. When an event of a certain type happens, you want to react, and there's a whole communication stream or something like that this all enables. Here's an example of a manufacturing dashboard where it's real-time manufacturing on the factory floor, where you want to see the current state of all of the machines on the factory floor and what's going on, energy consumption, any kind of thing. This may be a combination of sensor data combined with inventory, combined with sales and sales demand. You may be, in a manufacturing scenario, real-time reacting to market requirements based on orders, this kind of thing, cutting lead times to order delivery. There are tons of new opportunities for increasing the speed of business based on real-time data. So at this point, we've stored all the data in the data lake. We've ingested data and transformed it, normalized it, harmonized it, and made it consistent. Then we've done data science and data analytics to build models to gain insights, and we've added real time. So we have the whole stack. Now it's time, how do we consume this data? How do we see it, look at it, work with it? And for that, we're going to use Power BI. So Power BI historically has been a separate product. It's been merged into Fabric. So Power BI is now part of Fabric. And in Fabric, we can create interactive dashboards, graphs, charts, tables, connect to the semantic models, connect to tables, connect to external systems. Ideally, bring all those connections into the one lake or into real time and bring that all together into a unified view. But maybe a particular report needs to connect to something external and you don't want to go through all the process. You have that flexibility. Any of the Power BI connectors that you may be using now work fine. Then we can create advanced calculations using Power Query. You may not want to go down the data science route. You can do this right within Power BI itself. So there's a lot of options to tailor to the best solution to whatever your need is. And again, with the security, same security model, same RBAC applies across all of the same model within Fabric. And here's an example of a dashboard that Here's a sales and marketing dashboard, traditional Power BI. This may be connected to the semantic model. These components would be interactive, where you could click through and drill into different information in detail. Here's a similar dashboard. This one's on mobile, so you may have executives that prefer to use a tablet. Maybe they're on a plane and they just don't want to power up a laptop. They just want to go through, do a review of the business by just clicking on a tablet. That is also available. And in the latest versions, we have advanced visualizations. So here we're able to tap into Python and use the matplotlib library to bring in all kinds of very advanced visualizations like heat maps, histograms, all kinds of statistical analysis, depending on the complexity of your analysis needs. You have all the historical Power BI visuals, and now all the matplotlib visuals as well, which are quite extensive. Now, this is kind of at the complex high end of the scale, but of course, there's traditional reporting. So you may just want, hey, I just want a roll-up of sales by store in a region. And so, you don't need any of that visualization. You don't have to use it. It's fully available. And you may just say, hey, I just want a PDF of all the sales that happened last month, or whatever type of PDF report you want. It may be invoices that you're sending out. It may be statements. Fully supports creating standardized PDF reports. So that's PDF reporting. So now I'm going to go into the demos, and I'm going to demo AI skills. So I'm going to kick this one off here. Just like on. Oh, sorry about that. Well, okay, so on this slide is an example of the sales analytics model. So what's coming in here is we have a real-time data feed, and we have a batch of the data. So this is the historical sales data and the batch data. And the first thing we want on the real-time is looking for anomalies. So this may be a notebook that's going to run and collect up, and we're doing these the reflexes to catch anomalies in real time. Then we're going to bring that into the data store, where we're going to do some preparation, maybe clean up, harmonize customer names, any kind of store information, that kind of thing. And then we're going to feed that to a model. And that model is going to learn to predict, maybe do a regression or a classification, one of those models that we were looking at earlier. And with that training data, loop it back in into the data store, and then create a visualization. And that visualization, when we have the report, we can add a real-time track that we can add a reflex onto the output of the report. So we put the report together, and we're really happy with it. Say that manufacturing example we had earlier, that if, say, the battery level drops below a certain threshold, that we fire an event that gets tracked. Okay, so let's look at Power BI and Copilot working together. So here's the sales analytics portion. So we're going to click on a new item, and here you can see these are all the items within Fabric, and we're going to create an AI skill. So creating the skill, this is the Fabric interface, and we're going to be grabbing a data source from within the data lake, and you can see the different semantic models. And in this one is a KQL because we're doing a real time. So we're going to do a real time creation of a skill. And here we have a bunch of packages. So the data set, it's a package delivery company. And we're going to ask a question, hey, how many deliveries do we do in a month? So this question in Copilot is getting converted into that KQL query and coming out with this data set. And here you can see the query that it generated. This query, that way you're able to verify. You don't need to check every time, but if you're saying, hey, how did you come up with these numbers? If something doesn't seem quite right, you can look at the query, run the query separately, debug that, and understand where your data is coming from. Because traditionally, a developer would write those queries, and that's how they would surface up the report. But now with Copilot, you're able to ask in English, Copilot has the generative AI knowledge of how to convert your question into the proper language. So be it SQL, Python, or KQL, it's able to generate these questions of the semantic model. The other thing here, you can see now we're connecting a database together with the live package delivery. So this is historical data that we've stored along with real-time information, and we're joining those together. And you can say, what's the name of our top loyalty customer? And here comes, this is our top customer and lifetime sales of the customer. This is an individual, in your use case, it may be a company or a particular business that does that. And there's the query that generated that response. You don't need to look at the queries every time, but this is showing how it's coming up with that information. Then you say, what else can you tell? So here's some key information about the customer that's stored in the customer tables versus the real time. And again, you can expand that and see the query that generated that. In this case, it's a pretty simple query. Just select star from the customer table where the name is that. Not complex in that case, but again, as a user, this is talking to your data. This is what, if you hear the term talking to your data, this is what it means. And you can just keep drilling in as a business user. This is very empowering to business users that historically may not have known how to write queries. If you look at that query there that's on the screen, it's very complex. To a developer, that's their bread and butter daily thing. But to a business user, it's much easier to say, hey, can you show me the deliveries we did for this guy between these two dates? Or what did I do last week? So that's that demo. But here is the chat with your data demo. So we're going to hit Copilot, and here Copilot's going to interact with the semantic model again, and this time we're going to ask a different set of questions. How many different loyalty customers did we add last month? And these are the kind of things that historically would be reports. You may have to load up an Excel sheet, so your business users may have to load Excel, do a power pivot, do a pivot table, spend some time getting these answers. Historically, a big pain. Now, bringing this technology to your business users will really save time across the business. Okay, here's our loyalty, break it down by source. Well, here, okay, the app is definitely the source. And then who are the top members with anniversaries this month within the loyalty program? So maybe your marketing team just wants to know, who should we reach out to? So again, here it's surfacing up the data, and at any given time you have access to the underlying query, but an end business user can just keep asking these questions, and this is talking to their data. It'll run, the queries run within the context of the user, so they can ask questions about data they don't have access to, but it wouldn't respond there. And then here, there may be reports that exist in the business too. You may have tens or hundreds of reports in the business. The end user doesn't know which report to go to and where that information is available. So here's asking, hey, what report should I look at? And now when you bring the report up, you can ask questions about the report itself. And so everything we talked about here, the data lake, the one lake lying there, the data ingestion, the semantic model, and the data insight lead to this point where your end users don't need to see any of that. All they know is any report they need, they can just ask for it. Any kind of information they want, they can just ask using regular English, and they get the information they need. So that concludes the demo and concludes the presentation. Thanks for your patience during the little hiccup there. And thank you for coming out. All right.
Thank you, Shane.
Thanks.
Thank you, Shane. Thank you, everyone.
Thank you, Shane.
Take care.